Okay, so in this video we'll be working through a solution to a probability GCSE question that was sent in by a student. It says there are some red and some blue counters in a bag. The ratio of red counters to blue counters is 1 to 4. 2 counters are removed at random. The probability that both counters taken are red is 22 out of 35. Work out how many blue counters are in the bag. So we know that we've got a ratio of red to blue counters, okay? And the ratio of red to blue is 4 to 1, okay? So we've got the ratio of red to blue is 4 to 1, and that's the simplified ratio that we can have, okay? We can't simplify that ratio any further. So we can say that that ratio, when we add them together, is equal to 5, okay? Now, if I wanted to scale this ratio up, I could scale it to 8 to 2, and then it would equal 10 by multiplying by 2, okay? Now, we want to work out how many blue counters are in the bag, so we don't know what to scale our ratio up to. So what I'm going to do is I'm going to multiply all the parts of the ratio by x, where x is the same number, okay? So all I'm doing there is scaling the ratio up by x, multiplying all parts of the ratio by x, so we get 4x to 1x, and that's obviously going to be equal to 5x. Now what I'm able to do is work out an expression for the probability of a red being chosen, and an expression for the probability of a blue being chosen, okay? So the probability of a red being chosen is, and we show that with p and then in brackets what we're trying to get, the probability of red, is the part of the ratio that's red, so that's 4x, divided by the total, which is 5x. And we can see if we're to simplify that fraction, we get back to 4 out of 5, and that's what it would have been when we hadn't have scaled the ratio up by x. But we don't know what we need to scale it up to, so that's why we're going to leave the x's there, okay? Now I'm going to work out the probability of blue. And we know the probability of blue is going to be the part of the ratio that's blue, that's 1x, so we can just write x, divided by 5x. And again, that would simplify to 1 over 5, but we're going to leave the x's in there because we're trying to work out actually how many blue counters there are. So it says the probability that both counters taken are red is 22 out of 35. So we didn't actually need to work out the probability of getting a blue, but we've just done it anyway, so the examiner knows that we're just sort of getting as much information down as we can before we actually start the question. So it says that they're both taken are red, and that's 22 out of 35. So the probability of red, and then we've got another probability of red. So we want probability of red, and the other counter is probability of red as well. So we've got 2 red counters. When we're dealing with the word and in probability, we multiply the probabilities together. So we've got an and here, we want a probability of a red and then another red, so we're going to multiply them together. So the probability of a red on the first go is 4x out of our total 5x. We're dealing with the word and, so we're going to multiply the probabilities together. And then when we take the second counter, the probability that that's going to be red, well, we've already taken a red counter out, so we're going to have one less counter, which is going to be the amount of red counters before we took it out, then minus 1, because we've already took a red counter out on the first go. Then our total, we've already taken a counter out on the first go, so we're also going to have one less counter in total. So that's why we have to minus 1 from the top and the bottom. Now that will give us the probability that both of the counters are red. And we have the answer to that. It's 22 out of 35. So we can set this equation here equal to 22 out of 35. And all we're going to do now is simplify and solve for x. So we're multiplying fractions, so we just get top and top times bottom and bottom. So 4x times 4x minus 1 will be the top. And on the bottom, we will have 5x times 5x minus 1. And that's still equal to 22 over 35. Now what we can do is distribute the 4x with the 4x here and the 4x with the minus 1, the 5x with the 5x and the 5x with the minus 1. And we get 16x squared minus 4x divided by 25x squared minus 5x. And again, we're still equaling the probability of 22 over 35. Looking at the left-hand side here, we're able to simplify and we can cancel an x from every term. So we're going to get 16x minus 4 divided by 25x minus 5. And that's still equal to 22 over 35. Now what we're going to do is we're going to cross multiply. So we're going to get 35 times 16x minus 4 is equal to 22 times 25x minus 5. When we expand those brackets, we get 560x minus 140 is equal to 550x minus 110. And now we're just going to solve for x. So we're going to minus 550x from both sides. And at the same time, we're going to add 140 to both sides. So what we're going to get is we're going to get 10x, and then minus 110 plus 140 gives us 30. And then if we divide both sides by 10, we get that x is equal to 3. Now if we have a look back at our ratio, looking at this here, when we scaled everything up by x, we had red was 4x, blue was 1x. So the amount of blue counters, how many blue counters are in the bag, number of blue counters is equal to x. So x equals 3. So number of blue counters is 3. And that's your final answer.